Okay, guys. So I just want to perform some magic today. So what I've got here is it's not a black box, it is a mirror box. So sunlight can go through it, but we can't see what is inside. You will see there's little holes on the side as well, so air can nicely flow through this box. And the only thing I'm going to put into this box is a glass of tap water. Okay, so I got it from a tap, municipal water, and I put it in the box. Okay. Now, and this is where I perform the magic. I just leave the box. I let some air run through it. I give it some sunlight, and I just wait a while. And then, abra cadabra, what do I get out of the box? Okay, let's open up and see what's inside. Well, there is a glass of water coming out. But interesting, if we were able to analyze the water inside, we will find that it is now cleaner than before. But wait, there's more in the box. Let's have a look. What else is in the box? Oh, I got some nice salad coming out of the box. How nice is that? And there's more. If I look inside, hey, there's tomatoes coming out. Hey. And wait, last thing, there's a whole fish coming out. Okay. So how's this possible? I've just started with water. I ended up with cleaner water and a beautiful bunch of food. Is this magic? Yes or no? Okay, so now that I've shown you some magic, let's think of it in a chemical engineering way. And instead of going with a batch process like we done before, we now have a continuous process. Okay, and what we do is we say the only thing that goes over the boundary of this process is tap water. Okay, of course we allow some air, so that's not mentioned, but air can get in, so that's part of the plan. Air can get in, and of course you can also have some sunlight. Okay, those things are for free, but amazing that we can develop this continuous chemical process where we start with tap water, we clean the water, and we make food. I mean, how amazing is that? Think of it from an environmental perspective. Is this not the process that will save the world from its current downfall in terms of ruining the environment? So let's just do a bit of analysis on whether it's really magic. So to do this, we have to look at these magic products that came out of our process, the fish and the vegetables. Okay, so this leaves us with the question, what is food and biomass? Okay, and you guys are already familiar with CKN. Okay, so typically we use these 4 elements to describe biomass, but of course there's also some elements, some trace metals and cations and anions that we don't consider in CBI, but that is crucial in terms of making up biomass. So typically we have phosphorus, we have sulfur, we have potassium, magnesium, calcium. Those are called the macro elements, and those are, by the way, all present in water. And of course we also have some trace elements which are there in very small quantities. But have a look at this formula over here. Okay, we can write biomass as just the ratio of all these elements. Okay, we're not going to get into what the values of A, B, C, D, and E are, but biomass is really just a combination of these elements written down here. So the question now becomes, have we really performed magic? Yes or no? Well, if we look at it from a mass balance perspective, very important, these will be biochemical processes. It's not a single process, but we're only considering the boundaries of, let's call it a factory or a process plant, a biochemical process plant. Okay, so if we look at what comes out, clean water come out, clean water came in, so the water comes in, go out, okay. But if we have a look at the biomass, over here. It's just a formula consisting of our biomass elements. Okay, and you've done your mass balances in your second and your first year. Let's have a look. Are all these elements present in the incoming streams? Well, if we have a look at water, we can see that most of the elements or the minerals required are in tap water. Okay, fantastic. And then we have a look at the carbon. Where are we going to get our carbon from? Well, there's CO2 in the air. Where are we going to get our hydrogen and oxygen? Yeah, well, that's kind of easy. We got some water. But where are we going to get our nitrogen from? There goes nitrogen in the air. So you just bring it in through the air and it ends up as biomass. So maybe it's not magic. It is really possible. So let's do it like this. It is possible to drive this project, of this process, that appears to be magic. So my group have been working on this seemingly magic project. We call it Diazoponics. Okay, why do we call it Diazoponics? Well, we think of the nitrogen as crucial in terms of building the biomass. So you need all these elements to build the biomass, but you'll soon realize that nitrogen is one of the key elements in this whole process. And we call it Dihazoponics because in this process, there'll be Diazotrophs. Now, Diazotroph is really only bacteria or prokaryotes have this ability to fixate atmospheric nitrogen into usable formats for plants, etc. Very important, if we have a look at Diazoponics, we realize that what we're going to have inside, within the boundaries of this black box or silver box or blue box or whatever you want to call it, there'll be numerous process units. It's really a little factory we're putting together, and these units will be interconnected, given that the recycle of some of these elements will be crucial in the whole of this process. So we're not disclosing all the processes we'll have in Diazoponics. I just want you to realize that it will be an intricate combination of processing units. So the blue box is really a little plant, chemical engineering plant or chemical engineering factory that we have to develop. So today's little talk is not to explain all the aspects of Diazoponics, but for CLB 321, you will be working on sections of Diazoponics. So I want you to start thinking about this little magical process that I've just revealed to you. So your question is, how will you contribute in your CLB work to Diazoponics? And of course, we've just disclosed that there will be numerous units over there. So the question is, what units, possible units within the Diazoponics black box, which of those units will you be working with? Maybe just one, maybe two interconnecting ones, but I want you to start thinking about how all these units will fit together. So this is my last slide. I'll be leaving you to ponder about how this process will work, but I'm going to give you a little bit of a tip, and that tip is called Azolla. Azolla, what you see over here, is Azolla pinnata. I can write it down. Azolla pinnata. It is a local, it's sometimes called the water fern. You can read a little bit about it. I'm not going to give you a lot more detail on Azolla, but I see, in my interpretation of Dihazoponics, Azolla playing an important role in terms of getting this seemingly magic process to work. Okay, cheers CLB students, more to follow later.